we have this problem that is dealing with the impulse. And the impulse, as we know, I wrote the formula for you, is the force that applies to the object times the time. And it's going to be equal to the mass of the object times the difference in the velocities, the initial velocity and the final velocity. Now, this is different than the momentum formula. Again, the momentum formula is only the mass times the velocity. So if you notice the difference between these two formulas, the impulse is actually is the difference in momentums, because it is dealing with momentum in time. All right, so let's take this problem that is clearly an impulse problem. Why? Because we have the astronaut, we have the satellite, so there are two objects, and therefore we're going to have two different formulas since we have two different masses. However, we assume the initial velocity is 0, so the final velocity will be whatever the velocity we're gonna get. And in this case, we're going to find out the acceleration. We need to find the acceleration, which we all know the acceleration is the difference in the velocities over time, and be divided by the difference in time. However, in this case, the initial time is 0. That's why the time will be resumed to whatever the time is in this problem, given I'm assuming it's like 7 seconds for the B. All right, so the first question is, what's the acceleration? Well, if you notice here, if you divide each side by the time, you will come up with the force equal to the mass times the acceleration. So obviously, in order for you to find the acceleration, you're going to have to divide by the mass both sides, and you end up with the force applied to the object divided by the mass of the object. In this case scenario, we have two different objects. We have the astronaut and we have the satellite. So in order for us to find the acceleration of the astronaut, we need to apply the force. In this case, the force was 98, and the force is the same for both, because as you know, once you apply a force to an object, the object responds with the same force back. So that would be divided by the mass of the astronaut, which is 112 kilogram. Okay, so we're going to divide these two numbers, and whatever answer comes will be the acceleration. And the acceleration, in my case, it comes as exactly 0.875, and is the velocity divided by the time. So that would be meters per second square. And I'm looking here to see if we are dealing with meters. So it's going to be meters per second square. Same formula we apply for satellite, for the satellite. And the satellite will have a mass. So it's the same force, but the mass of the satellite is 800 kilograms. Okay, so in this case scenario, we'll have 98 divided by 800. And that gives me 0.1225 meter per second square. For the B part, well, how far away is the astronaut? Obviously, you're gonna have to apply the formula for the acceleration, and versus, of course, you need to find the velocity first, and then you can find the distance. So the acceleration being the velocity in time. Velocity, again, is the difference in the distance over time. Obviously, my bad, the time square. You have to multiply with the time square both sides, so you end up with acceleration times the time square. And you know the acceleration from the previous question, and the time square you have 7 seconds. So you're going to just plug it in. Acceleration again is given, so you're going to multiply 0.0875, and then you multiply with the time, which is 7 seconds, so you say 7 square, and whatever that answer is will be your distance in meters. I will let you finish that on your own. The second question is referring to the same formula. It's a problem where we have a mass of the gas particles with a certain with mass in grams. The velocity will come as 1400 meters per second. So if I am applying the same formula, I'm ending up with the force times the time equal the mass times the difference in velocities. Since the initial velocity was 0 and the final velocity is 1400 meters per second, we're going to just assume that, we don't assume, we know the 1400 is going to be replaced in the formula for the dV. Then the mass of the particle is known. That will be replacing the m. The time of the explosion is given 0.0016 seconds. That will replace the time. So the only variable that you need to know is the force F. And in this case scenario, you're going to have to divide both sides by the time. So you have the force equal to the mass 0.00035 times the velocity 1400. We're going to handle the units at the end. Divided by the time 0.000. That is not the time, my bad. The time was 0.0016. And the final answer will be, after you compute this, I'm going to let you use the calculator to save time. And the final answer will be in newtons for this problem. I hope this helps. The only issue that we have so far, because we need the newtons should be the final answer, newtons are represented in kilograms times mass times seconds to the -2. And my problem does not have kilograms. If you notice, has grams. So we're going to have to change the grams in kilograms. So this unit of measurement, because it's in grams, we have to use kilograms. So how we change that from grams to kilograms, you divide by 1,000. So you technically have to move the decimal points 3 more units to the left. So technically what we're going to do, I'm going to write here for you, in order for me to keep the newtons, it will be 0. And instead of 3 zeros that we have to add 3 more. And then we have 35 times 1400 divided by 0.0016. And then we can say newtons. So this is not in newtons yet. You have to divide by 1,000. Okay, now the problem should be final after you do the calculations in the calculator.